It would take between 1,000 and 81,000 years for a spacecraft to reach Alpha Centauri if we used conventional propulsion. Plus, astronauts would have to deal with the countless risks of the mostly unexplored interstellar medium. But there might be a way out of this seemingly hopeless situation. Gram-scale spacecraft that rely on lasers when it comes to traveling through space. One of such concepts is called the swarming Proxima Centauri, and it has recently been chosen for the NASA Innovative Advanced Concepts program. You see, traveling through interstellar space is a question of speed, energy, and distance. Proxima Centauri sits 4.25 light-years away from the solar system. That's 25 trillion miles, which is incredibly far away. For comparison, the farthest distance ever traveled by a spacecraft is 15 billion miles from Earth. Voyager 1 has been moving in outer space for more than 46 years, reaching a maximum speed of over 38 miles per hour. Traveling at the speeds that we can allow at the moment will make interstellar transit exceptionally long and totally impractical. And don't forget about the energy requirements such a journey would demand. Anything other than a tiny spacecraft weighing a few grams doesn't look feasible. But the solution might have been found. Bouncing photons off of a laser sail could solve the speed problem. But since a single photon doesn't have much momentum, a lot of them are needed. And since even in a couple of decades we probably won't have a lot of power available, the thrust will be weak. That's why the mass of the probes has to be minuscule. Not tons, but grams. The proposal suggests using a 100-gigawatt laser beamer, boosting thousands of tiny space probes with laser sails to a speed of 10 to 20% of the speed of light. This mission concept might be ready for development around mid-century. Then, the probes could reach Proxima Centauri as early as 2075. The researchers involved in the project have already demonstrated how a fleet of 1,000 spacecraft could deal with the difficulties of interstellar travel while maintaining communications with Earth. At the same time, the 8-year round-trip time lag caused by interstellar distances and general relativity makes it impossible to control the swarm of the probes from our planet. That's why the fleet must possess a great degree of autonomy when it comes to navigation and deciding what data should be delivered to Earth. One more issue is the cost of such a mission. The greatest expense will be the laser array, while the tiny probes might be reasonably cheap to produce. The scientists believe that their project can be developed with a budget of $100 billion. It's not so much compared to the usefulness of such a mission, which is likely to be astronomical. How come? Red dwarf Proxima Centauri, which is a member of the Alpha Centauri star system, has an Earth-like planet orbiting it, Proxima Centauri b. It's the closest exoplanet to Earth. Its mass is similar to that of our planet, and it travels in the habitable zone of its parent star, which means there might be water in this world as well as an atmosphere rich with oxygen. This planet might harbor life, or it could be a dry rock. In any case, it's a promising target in the search for alien life. Unfortunately, we can't detect the planet's biosignatures because our usual methods for detecting them don't work with Proxima Centauri b. Most exoplanets are discovered and explored through the transit method, where a planet regularly passes in front of its parent star, and we see a recurring dip in the star's brightness. That's how we know that the planet is there. But Proxima Centauri b isn't a transiting planet. It was discovered by a different method. When we look at the light coming from Proxima Centauri, we can notice that the gravitational pull of Proxima Centauri b makes the star wobble a bit. That's how astronomers found out that the planet was there. They also managed to estimate its size and mass. But no one can figure out much more than that. Hopefully, a swarm of tiny space probes will help us solve this mystery.
Venus has more volcanoes than any other planet in the solar system, more than 1,600. And a day on Venus, measured by how long it takes to rotate once on its axis, takes longer than the time it takes to complete a full orbit of the Sun. Wow! And that's just Monday. An extreme greenhouse effect warms the planet's surface up to 870 degrees Fahrenheit, hot enough to melt lead. Winds there reach the speed of 450 miles per hour in the middle cloud layer, faster than the speediest tornadoes on our planet. The pressure on Venus's surface is 90 times higher than that at sea level on Earth. What a great place for a vacation, huh? And recently, this incredible place has become even more intriguing. In the toxic Venusian atmosphere, there's something that might mean the existence of life. Unfortunately, scientists haven't had a chance to collect any microbe specimens or snap any pictures of life there. But they've discovered a chemical called phosphine, and it's a big deal.
If it's not some previously unknown chemistry that produces the gas, then there must be a kind of microbial life involved in the process. Phosphine is made up of 3 atoms of hydrogen and 1 atom of phosphorus. This gas is toxic to any normal life form that needs oxygen, including us humans. On our planet, phosphine can be found in places with no or little oxygen, for example, marshes and swamps. The gas is created by complex mixtures of bacteria living there. It can also be produced industrially.
The weirdest thing is that phosphine isn't supposed to be in Venus's atmosphere at all. This gas needs precise pressure and temperature and tons of hydrogen to form. It wouldn't be all that surprising to find it on Saturn or Jupiter, the famous gas giants, but on Venus? Totally unexpected. There's no way phosphine can be produced naturally on this planet. Tiny amounts of it can be created during volcanic eruptions, lightning storms, minerals blown up to the surface, or meteorites entering Venus's atmosphere. But it's not nearly enough to explain what the astronomers have observed. It would only make 1/10,000th of the phosphine the telescope saw.
But let's start from the very beginning. In 2017, a group of scientists led by Jane Greaves from Cardiff University started to use the James Clerk Maxwell Radio Telescope in Hawaii. That's a mouthful. The main idea was to search for phosphine gas. It would be a sign of life on Venus. When the data came back and the researchers analyzed it, they were shocked. The phosphine signal was powerful. The team checked the results several times. They wanted to make sure no other substance mimicked the presence of phosphine gas.
So now, does it mean there's life on Venus? Not necessarily. If this gas is created by some mysterious organisms, it's a big question how they survive on Venus. On our planet, some microbes can thrive in the environments with the acidity of 5%, but no more. On Venus, though, clouds are almost entirely made of acid. And even though they have a rather pleasant temperature of 86 degrees Fahrenheit, these clouds contain more than 90% of sulfuric acid. DNA, amino acids, proteins, life components on Earth would be dissolved there in the blink of an eye. The surface of the planet is too hot for any kind of complex molecules to make up life. The Venusian atmosphere is almost 50 times as dry as the driest place on our home planet. There's a theory that microbes might hide in scarce water droplets floating in the atmosphere, but it hasn't been proved yet.
Right now, the research team's waiting for more telescope time. They're going to look for other gases associated with life. But even if they find more evidence, life forms on Venus will be made up of building blocks absolutely different than those on Earth. Or they might be protected by a sulfuric acid-resistant shell. It can be made of such substances as sulfur, wax, graphite, or something else we can't imagine.
Of course, some experts question the idea of life on Venus. They think the gas might be produced during some geologic or atmospheric processes happening on the planet. But the supporters of both theories agree on one thing: the discovery is extraordinary. Interestingly, astronomers have always tried to find signs of life on giant planets' icy moons, or even closer, on Mars. But they've never seriously considered Venus. If additional telescope observations and future space missions confirm that phosphine is produced by living organisms, we can be in for a bunch of exciting surprises. Then people would know of a planet with an alien biosphere, well, alien to us, and this planet would be just next door to Earth. Now, speaking of visiting Venus, though, would it be possible for people to land on this planet? After all, robots are already tooling around the red planet surface. On the pro side, Venus is closer to Earth than Mars, but it also has much harsher conditions. The planet is hotter than Mercury, even though Venus is almost double the distance from the Sun. The temperatures are higher than the melting point of many metals, and some of them, like lead or bismuth, can fall as snow on the highest mountain peaks. If you set foot on the planet, you'll find nothing but barren rock. Giant basaltic plains are littered with volcanoes and mountains. In some places, the surface melts because of the heat underneath. After it releases some of it, the rock solidifies again.
If people ever go to this planet, they will most likely build floating cities in the clouds of Venus's atmosphere. At about 31 miles above the surface, the conditions, like the pressure and gravity, are similar to those on Earth. The temperature is rather manageable too, at around 167 degrees Fahrenheit. Think Death Valley, California on a really hot day. The atmospheric pressure is half of what we have at sea level on our planet. If you went outside, you'd be fine without a pressure suit. The pressure you'd feel would be the same as at the top of Mount Kilimanjaro. Plus, this colony would be protected from the sun's radiation better than one on Mars.
If the atmosphere was the mission's final destination, landing a spacecraft, or rather making it hover in the air, would look very different. The idea is to use an airship in the upper atmosphere for long periods of time. The airship, wrapped in an aeroshell, would enter the planet's atmosphere at a speed of 24,000 feet per second. In the next 7 minutes, its speed would drop to around 1,500 feet per second. After that, a huge parachute would open. It would slow the spacecraft down even more, and then things would get a bit hectic. The aeroshell, not needed anymore, would drop away. The airship would then inflate itself, all the while hurtling through the atmosphere toward the planet's surface. Its speed would be at least 330 feet per second. It would get larger and larger, and its drag and lift would increase. Soon, the parachute wouldn't be needed anymore. The crew would get rid of it, and the airship would fill with air completely. If everything went as planned, it would stop 30 miles above Venus's surface. After that, the airship would travel around the planet. It would be moved by the wind, which can reach a speed of 220 miles per hour at the top of the cloud layer. If you decided to move closer to the surface, though, you'd have to be extremely careful. The wind in the middle layer can get twice faster. The airship could be filled with a breathable mixture of hydrogen and oxygen gases. Such a combination would be less dense than the Venusian atmosphere. It would provide the needed buoyancy, to stay up there. Venus is famous for its super dense clouds. These clouds make the planet shine bright enough to be seen from Earth. Venus reflects more than 75% of the light that comes from the Sun. This reflective cloud layer exists thanks to a haze of sulfuric acid droplets in the atmosphere, and they gather exactly at the height where the airship would float. Luckily, people already have a method to overcome the problem of acidity. A few materials, for example Teflon and some types of plastic, have an amazing acidic resistance. They could protect the outsides of the ship. So, let's say you needed to work on a platform outside. Then you'd be able to do it, wearing only a chemical hazard suit and carrying necessary oxygen supply. Ooh, sounds like fun, huh? Yeah, me neither. You're gazing up at the night sky. Wow! For much of our history, we've been looking for life among these stars and the planets near them. But space has eyes too, and there's someone out there looking at us, maybe. Scientists claim that at least 29 distant planets may be watching us right now. So comb your hair and smile. We've so far identified at least 1,715 neighboring star systems in the Milky Way that can detect our planet with conventional telescopes. These stars are located in our galaxy. So if they were to point their telescopes at our Sun, sooner or later they would see a small dot that passes between our home star and the observer. This is called a transit. It's a method of detecting planets in astronomy. For example, you can observe transit phenomenon right at home with a telescope. You have to point it at the Sun and wait. Then you'll see Mercury. That's the closest planet to the Sun, and now you see it as a small dot. Mercury transit process can last about 5 hours, and this phenomenon happens about 14 times in a century. you'll be able to observe the next transit on November 13, 2032. Mark your calendar. Likewise, you can observe Venus, the second planet from the Sun, but because it's farther away, its transits are less frequent. The last one was in 2004 and 2012. The next pair of transits is expected in 2117 and 2125. Hey, I won't be around then. So these star systems have the opportunity to observe our planet. But long-range telescopes work a little differently. Actually, the observer will not see a black dot with the sun in the background. The telescope will measure the brightness of our star. When Earth begins its transit between the sun and the observer, the telescope will record a slight drop in the brightness of the star because our planet is blocking the path of the sun's rays. Those faraway scientists of extraterrestrial civilizations will be able to calculate this drop in brightness and determine the size of our planet. But not all 1,700-plus star systems may have extraterrestrial life. Scientists have narrowed it down to 29 planets near some of these stars. They're potentially habitable. That means these planets are roughly Earth-like in size and within the habitable zone of their host star. That means they're not too close to the star, so it's not too hot for potential life. The water doesn't evaporate there like in a boiling pot. And they're not too far away, so it's not too cold and the water doesn't freeze into thick sheets of ice. And since water is the basis of life, we can assume that civilization might exist there. Theoretically, these planets could have seen Earth transits in the last 5,000 years. So, while we were building the pyramids of Giza or Stonehenge, an extraterrestrial civilization may have been watching us. One of these planets is only 11 light-years from our home. Near the Ross 128 star, a red dwarf in the constellation Virgo, there's an exoplanet about twice the size of Earth and right in the habitable zone of its host star. Theoretically, the inhabitants of this planet could see Earth transit the Sun on a regular basis for 2,000 years. But about 900 years ago, the planet lost its position and can no longer continue observation. The other planet where Earth can be seen transiting is 12.5 light-years away, near the star called Teegarden. The window for observing our planet will open there in about 29 years. We're betting heavily on the TRAPPIST-1 star system. It hosts at least 7 exoplanets, almost like our solar system. And 4 of them are in the habitable zone of the star. But they won't be able to start observing Earth until 16 centuries from now. But we can try to make contact with these planets right now. They're all close enough to us to pick up our radio signals. Radio waves can travel through space at the speed of light, and our planet has been emitting radio signals continuously since 1895. So we're like noisy neighbors in the radio spectrum. If there's a planet somewhere with an intelligent civilization within 125 light-years of us, our radio noise would have already reached them. The only problem is, it would take about the same time to get a response from that civilization. The other problem with radio is that any civilization uses it for a relatively short period. Even now on Earth, we use Bluetooth and fiber optics more than radio, except for maybe traffic reports. And over time, all the radio noise we create will simply disappear. Also, radio communication assumes that an extraterrestrial civilization is advanced enough to use this technology. But who knows? Maybe there are life forms in space that are really different from ours. Our radio signals already could have reached that planet, but its inhabitants simply aren't capable of receiving them. And the moment these life forms build antennas to receive the signal, we'll no longer emit them. But we don't lose hope, and we even send encrypted radio signals into space to communicate with extraterrestrial civilizations. In 1974, we sent the Arecibo message into interstellar space. If some civilization can decipher it, they'll get a rectangle like this. It has all the information about humanity. At the top is our number system, then the atomic numbers, and then our DNA, which is pictured below. Then a human being itself, of course.
Below is a diagram of our solar system. Earth, the third planet from the Sun, is slightly elevated. This is how the extraterrestrial civilization will understand which planet this message came from. Below is a diagram of the Arecibo radio telescope itself. Another option how to deliver a message to a distant planet is to literally send a mail delivery there. It could be a space probe. And we've already done that. These are Voyagers 1 and 2. They were launched in 1977 and are still operational. In 2012, Voyager 1 became the first ever human-made object in interstellar space. It travels to distant stars and carries a message written on a golden record. The disk contains greetings in 55 Earth languages, a lot of music from different parts of our planet. Different sounds like ocean noise, human voices, and animal sounds. In addition, there are 116 images on the record. These are pictures of people and earthly landscapes. In these pictures, there's information about the Sun and our DNA. The record case contains instructions and a needle to play the record. There's also a map of our galaxy's pulsars so that astronomers from an extraterrestrial civilization can find our solar system. The main disadvantage of sending a message this way is time. Voyager 1 will reach its first stop, the Gliese 445 star, in 40,000 years. Voyager 2 will reach the Ross 248 star in 42,000 years. And in about 296,000 years, it'll pass Sirius, the brightest star in the night sky. I can't wait. Also, an extraterrestrial civilization can detect us with calculations and formulas. All it takes is a little observation of the Sun. In star systems with planets, the host star doesn't stand still. It rotates around a small orbit. This is because the heavy star attracts the planet, but the planet also has its own gravity and resists. This shifts the star a little and causes it to orbit around. An extraterrestrial civilization can calculate this shift of the Sun and determine the mass of the planets near the star. Using such a method, astronomers were able to find 548 exoplanets. Now suppose we made contact with an extraterrestrial civilization near the closest star, Proxima Centauri. There's indeed an exoplanet there, but radiation from the host star would destroy any life forms. But imagine we still got a return signal. It would be the slowest chat in history, because our message would take 4.2 years to reach the planet, and we'd have to wait another 4.2 years to get a response. And so we arranged to meet. This civilization doesn't know how to fly into space. So we have to take the first step. Although Proxima Centauri is the closest star to our solar system, it takes about 73,000 years to travel there by conventional rocket. So we have to learn to travel at the speed of light. But even then, it would take 4.2 years to travel there. Imagine if we found extraterrestrial life on the other side of the Milky Way. Our galaxy is 100,000 light-years wide. So the journey from edge to edge would take 100 millennia. So, we either have to cheat the laws of physics or transfer all of human civilization to a giant spaceship that will travel from star to star for thousands of years. And when it launches from Earth, only the great and many more greats of the first crew will be able to see another star system from the spaceship portal. Hey, can you move your head? I'm trying to see out the window.
One of the biggest questions that has been torturing the minds of astronomers and common folks is, why haven't we found aliens yet? You'd think with a universe so big and filled with tons of stars and planets, we'd have already bumped into some extraterrestrial neighbors by now. This question was first asked by famous physicist Enrico Fermi during a lunch with his fellow scientists. They were chatting about UFO sightings and aliens, and suddenly Fermi asked, "Where is everyone?" It seemed like a casual comment, but it sparked a huge debate. If the universe is packed with stars, planets, and the possibility of alien life, how come we haven't seen any yet? This discussion gave birth to something we now call the Fermi paradox. It goes like this. Based on what we know, there should be advanced alien civilizations out there, perhaps even many of them. They'd likely have technology that could allow them to travel across space or at least send us signals to let us know they're there. But here's the kicker. Despite all of our technology and all the searching we've done, we haven't found a single shred of solid proof that these advanced civilizations do exist. So where are they? Over the years, a lot of theories trying to explain this paradox have seen the light of day. Let's talk about some of the most interesting ones. The rare Earth hypothesis claims that Earth might just be super rare, and planets like ours, with life, are incredibly uncommon. In this case, we could be the only planet in the Milky Way harboring life, or at least intelligent life. We might also be the first intelligent civilization in our galaxy to reach this level of development. In other words, we could be pioneers, however unbelievable it may sound. At the same time, it's not very scientific to rely on a rare chance. Some people think that maybe advanced civilizations were once here, but left the Milky Way. Perhaps they developed the technology of interstellar travel, enabling them to fly between galaxies. Or they could use other exotic ways, like wormholes, hypothetical structures connecting disparate points in space-time. Maybe they found more interesting and pleasant places to live far away from us. One sad possibility is that when a civilization becomes too advanced, it ends up destroying itself. Whether through war, environmental destruction, or something else, it could be that most civilizations don't last long enough to reach out to others. Now, imagine an advanced civilization being wiped out by a disease before they could even start exploring stars. In other words, it's possible that civilizations just don't survive long enough to meet others. Another hypothesis, not very flattering to us. What if these aliens are using technology that we just don't understand? Maybe they're communicating in ways we can't detect, like using signals beyond our current understanding of physics. Scientists are discussing such possibilities, but haven't found any yet. Aliens might also be intentionally avoiding us. They could be out there but staying silent, not so eager to reveal themselves until we're ready. Speaking of being ready, some people think that aliens could be waiting for us to reach a certain level of development before they make contact. Maybe they don't want to interfere with our growth until we're more advanced. Advanced civilizations could also go into virtual realities. And if they can live in digital worlds, they might stop caring about exploring the physical universe. Why bother? Another wild idea is that some civilizations might go into a type of hibernation, waiting for the universe to cool down, because it might be more energy efficient to do so. And last but not least, there's this creepy possibility that our entire universe is a computer simulation, and aliens are hidden from us on purpose. It's something like a video game that doesn't reveal all its secrets at once until you get to the next level. Now let's talk about the odds of life out there. We know that in just our galaxy, the Milky Way, there are probably around 20 billion planets that are roughly Earth-sized and located in the habitable zone, which means they're just the right distance from their stars to have liquid water. But how many of these planets actually have life? Could it be most of them, just a few, or almost none? And out of the planets that do have life, how many host intelligent beings with technology? In the 1960s, a scientist named Dr. Frank Drake tried to estimate the number of civilizations in our galaxy that could contact us. He came up with a famous equation, later called the Drake equation. It looks complicated, but the idea is pretty simple. It helps us calculate the number of intelligent civilizations based on things like how many stars are born each year, how many have planets, how many planets could support life, and how long a civilization might last. Here's what it looks like. Let's look into this equation in more detail. N is the number of intelligent civilizations that could contact us. R is the rate of star formation in our galaxy. FP is the fraction of stars with planets. NE is the average number of planets per star that could support life. FL is the fraction of those planets where life actually develops. Fi is the fraction where intelligent life arises. FC is the fraction of civilizations that can and want to communicate. L is how long these civilizations last before they disappear. The problem is, we don't know the exact values for most of these factors. So when we plug in numbers, which we know with large errors, we get answers with very large errors too. Depending on the values, the number of civilizations in our galaxy could be anywhere from almost 0 to tens of thousands. Right now, the best estimate we can come up with gives us a very small number, close to 0. In other words, even though our galaxy is huge, it's possible we're all alone here. Or nearly alone. One big reason we haven't met any aliens yet is that even if they do exist, we might not be able to visit them, at least not with our current technology. The speed of light is a hard limit in physics, meaning nothing can travel faster than it. This makes interstellar travel super slow. The situation could be better if there were exotic ways of travel, such as wormholes and warp drives. One day, they may turn out to be real, but so far, there is little hope for that. Even if we can't meet aliens face to face, there are still ways we might discover them. One of the biggest projects is called SETI, Search for Extraterrestrial Intelligence. SETI scientists use huge telescopes to listen for radio signals from distant planets. If an alien civilization is sending out signals, we might be able to pick them up. And if we have a very powerful telescope, we might use it to take super detailed pictures of distant planets, maybe even Earth-like ones, hundreds of light years away. This could give us a whole new way to search for signs of alien life. In any case, even though we haven't found aliens yet, the search is far from over. Whether it's through new technology, better understanding of physics, or just listening to the stars, we might one day find that we're not alone in the universe. Until then, the question, where is everyone, keeps sparking curiosity.
Chances are, we're going to find life beyond Earth by 2035, and there's no need to travel to a galaxy far, far away. Our Milky Way galaxy is full of totally suitable environments. Don't get too hyped up though. We're talking about microbes or chemical markers, not Hollywood-like green humanoids. Even so, when we finally find traces of life, it will change how we see our place in the universe. NASA's Kepler Space Telescope discovered something incredible. Almost every star has planets, and many of these planets might be habitable. Rocky planets like Earth and Mars are even more common in our galaxy than gas giants like Saturn and Jupiter. Also, we already know that our galaxy is very rich in water. There's water in interstellar clouds where stars and planets form, in the debris disks around other stars, in comets, just everywhere. What's really hard though is finding life itself. Ideally, to finally find it, we need to land on every single planet out there and literally check under each rock. But thanks to the newest research, we can at least narrow down the search to potentially habitable worlds. The James Webb Space Telescope, a super powerful telescope that was launched into space in 2021, is onto this. It checks the atmospheres of nearby super-Earths, rocky planets that are a bit bigger than Earth. It searches for life-related gases, chemicals that can only be produced by living things. And they already found some clues. For example, they detected signs of such a chemical on a planet called K2-18b. This planet is 120 light-years away, which is pretty close on a space scale. This planet is in the Goldilocks zone, which means a zone around the star where the temperatures are just right for liquid water to exist. It orbits a red dwarf star, the smallest type of star there is. Such stars are a bit fainter than our Sun. It will take about a year to check if these hints of life are real. If so, it would mean that life is much more common than we previously thought. But even if it's not, there are 10 more Goldilocks planets on their list to study. The James Webb Space Telescope is a very cool tool, but it has limits. It can't detect small Earth-like planets due to their size. To fix this, NASA plans to launch another tool, the Wide Field Infrared Survey Telescope. This one will be even better at spotting such planets and life-related chemicals. And also, we have the SETI project. SETI stands for Search for Extraterrestrial Intelligence. This project has been on a hunt for extraterrestrial creatures since the 1980s. They also believe that we'll find signs of life within the next 10 years. Not so long ago, they started a super big and cool project. It's called COSMIC. and it uses an array of radio telescopes in New Mexico. You might have seen those in the movie Contact. Cosmic allows scientists to listen to hundreds of thousands and potentially millions of star systems at the same time. If there are any interesting signals, scientists can check them right away, instead of waiting for weeks or even months. The signals themselves are often very sudden and short, but Cosmic can detect even the shortest ones that last nanoseconds. Cosmic can also help with other research, like studying mysterious and unexplained fast radio bursts, or even dark matter. This is the biggest and most powerful tool for searching for extraterrestrial life we've ever created. But it's not enough to just listen. Why don't we reach out ourselves? NASA has sent some signals into deep space. In 2002, their Deep Space Network sent a signal to the Pioneer 10 satellite. But there was an obstacle in the path: a white dwarf star 27 light-years away from Earth. If there's a planet around this star, perhaps the signal reached them too. If there are any intelligent species there, we could receive a reply by 2029. The DSN keeps sending powerful transmissions into space. These signals will bump into 222 stars within the next 3 centuries. Maybe someday we'll receive a reply from somewhere far away. But why haven't we received a response yet? There are about 200 billion galaxies in the universe, each with around 100 billion stars. If just 1% of those stars had one planet, that's still 200 quintillion possible planets. And we can narrow it down even further. If the chance of them having life is 1 in a trillion, that would still leave us a few 100,000 planets. So, where is everyone? This is a famous question known as the Fermi paradox. The first possibility isn't that terrifying. It's possible that the universe is full of life, but this life isn't intelligent in our traditional sense. Some planets might have microbes, birds, or space dinosaurs. This is called the Great Filter Theory. It suggests that there are certain filters that life has to overcome in order to become intelligent, and maybe other species just haven't overcome them yet. Think about it. Life on Earth started in the ocean, then crawled onto land, diversified into many forms, went extinct in massive events 5 times, evolved again, and eventually led to humans. We built societies, developed healthcare, and only then started searching for another life. There's another idea called the Gaian bottleneck hypothesis, which suggests basically the same thing. While it might not be too hard for basic life to start, it's incredibly tough for that life to survive and thrive over long periods. Venus might have had oceans and Earth-like conditions too, but something went wrong. Its oceans boiled away because of a runaway greenhouse effect. Now it's sterile. Mars also had liquid water on its surface once, and both the Moon and Mercury had thick atmospheres for a short time. Meanwhile, Earth has had liquid water on its surface for almost its entire existence. It's super rare and remarkable for a planet to hold temperatures from 32 to 212 degrees Fahrenheit for millions of years. So, maybe it's a mistake to look for intelligent life, especially the one that uses the same technology as we do. It evolved under completely different conditions after all. That's also where the so-called Drake equation comes in. It's a formula that gives us a chance to calculate the potential of life becoming intelligent on a planet. To calculate the result, we need to know several variables: how many stars there are, how many of them have planets, the chance of these planets having life, and so on. Unfortunately, we don't know these numbers yet, and the result might be insignificant. But let's assume that there is at least one other intelligent species. Why haven't we met yet? There might be many reasons. Maybe they don't think we're interesting enough, or maybe the problem is with us. Perhaps we keep missing their signals, or maybe we missed the entire species itself. The universe is insanely huge and ancient. It's over 14 billion years old. If we compress Earth's entire evolutionary history into a 24-hour day, life starts at 4 a.m. Dinosaurs go extinct at 11:40 p.m. Human-like creatures appear 2 minutes before midnight. In this analogy, humans have existed for just 77 seconds, and our technology capable of detecting extraterrestrial life is even newer, less than a second. With such vast distances and time spans, the chances of us existing at the same time as other civilizations are slim. If their civilization lasted only a few millennia, we could easily miss them entirely. But that doesn't mean we should give up our search. Scientists were worried that Earth's radio signals had dimmed over time. But a recent study showed that it's actually the opposite. The numbers of our satellites keeps growing, and this makes our planet more detectable. By the end of the decade, we could have 100,000 satellites, making Earth incredibly bright in the radio spectrum. If there is an advanced civilization out there, they will easily spot us even from very far distances. Astronomers are super optimistic about it. There's a high chance they'll find extraterrestrial creatures while you and I are still around.
The search for ET is on. It's most definitely on. With the successful launch of the James Webb Telescope, the search for Earth-like planets has become a riveting topic of worldwide attention. Apart from the James Webb Telescope, other tools are being used to find good Earth-like candidates. The TESS satellite and the Kepler telescope are at the forefront of searching for other Earths. After we first clear the air of a few pesky philosophical questions, we'll take a close look at these two searches and what the James Webb Telescope hopes to find. So, why are we searching for Earth-like planets? Well, because we can. Incredible advances in Earthbound telescope technology have enabled ultra-precise observations of starlight, which led to the earliest discovery of exoplanets. As planets go around stars, there's a gravitational interaction between the planet and the star. They pull each other. The planet's pull upon the star will cause the starlight to wobble back and forth ever so slightly as the planet or planets orbit the star. This has always been the case, but the wobble of the starlight was never able to be detected because starlight always twinkles. You know, twinkle, twinkle, etc. Adaptive optics inside telescopes is the technological breakthrough that first enabled astronomers to find exoplanets by taking the twinkle out of starlight. Mechanical springs on the underside of telescope mirrors bend the mirrors ever so slightly to neutralize the distortion, the twinkle, caused by starlight passing through Earth's atmosphere. Without the glimmer of starlight, the slight wobble caused by planets pulling gravitationally on the stars is observable. The bigger the wobble, the more planets. It's called the astrometric method of exoplanet detection. Isn't that a mouthful? Whole star systems and literally thousands of exoplanets were inferred to exist around nearby stars by analyzing the wobbly patterns of starlight. But the planets themselves could not be seen. Suddenly, our solar system was not unique anymore. Astronomers got giddy over the inescapable conclusion that probably every star had planets. It became impossible not to ask the poignant question, is the Earth unique, or are there other Earths? What's the big deal about finding Earth-like planets anyways? Well, considering all the financial resources the developed countries are spending on finding Earth-like planets, it can be said without a doubt that it's definitely a big deal. Including the launched James Webb Telescope, which cost $10 billion, the Kepler Space Telescope, which cost $550 million, and the TESS satellite, which cost $200 million. The investment in finding Earth-like planets is certainly eyebrow-raising. Now, if you keep in mind that these costs are just for the hardware, and to get a sketch of the full magnitude of the search, you must also include the salaries of a team of data miners, PhD analysts, and postgrads all across the globe in universities, national space agencies, and private institutions. We will conclude that finding another Earth is truly an immense undertaking. Now, suppose we find one. Then Earth is not alone anymore. It's not that we can actually go to any of these planets anytime soon. Interstellar travel requires some breakthroughs in physics and technology, and, well, we aren't there yet. But knowing that there are planets out there in the Milky Way that are like Earth in all the essential respects, like liquid water, oxygen, and habitability, will make space less foreboding, more welcoming, more exciting to study and explore. It may also give us some more pride in our home planet and make us all better Earthlings. The triple mission looking for other Earths, the Kepler telescope, the TESS satellite, and the James Webb telescope, use distinct approaches to find exoplanets, and the synonym TESS tells us what that method is. The T stands for transiting, and that's the key to the whole exoplanet search. E stands for, you guessed it, exoplanets, the target of the excellent investigation of another Earth. S stands for survey, because TESS looks at hundreds of thousands of nearby stars. And S stands for satellite, because TESS is orbiting Earth, unlike the James Webb Space Telescope, which will orbit the Sun. When a planet passes in front of a star, that is called a transit. The planet will block some of the light coming from the star. This decrease or dimming of the star can be measured. The dimming of starlight tells lots of things about the planet. By knowing how bright the star is and how much the star's light was dimmed by a transition in front of the star, we can tell how giant the planet is or how close it is, but we won't know which. Is it big or is it close? Until the planet's orbit is also timed. It means our test satellite must take long-duration videos of the stars. Ooh, video of the stars. Hollywood should like that. The test satellite doesn't have a telescope. It uses 4 CCD cameras to stream live long-duration videos of as many stars as possible, hundreds of thousands of stars. Why so many? Well, because for a transit of a planet to be observed, it must pass directly between the test satellite's cameras and the star. If the planet is not on the exact line-of-sight angle between the star and TESS's cameras, it cannot be seen because it will not cut off any starlights. Planetary transits are rare. For example, Venus passes across Earth's view of the Sun only every couple hundred years, yet TESS's cameras are seeing many planetary transits among the hundreds of thousands of stars it takes streaming long-duration videos of, and you know what that means. It means there must be hundreds or thousands of times more planets than are observed by the transiting method. It is, therefore, an inescapable conclusion that every star has planets. Planets are everywhere. And now, the James Webb Space Telescope, with its giant 21-foot, 4-inch wide mirror, is entering the search. It is a technological marvel, a wonder of the modern world, a miracle of advanced engineering. Anticipation is reaching a fever pitch. But with the heightened anticipation comes an almost equal amount of trepidation. And some things can still go wrong before the James Webb Space Telescope returns its first pictures. After the Hubble Space Telescope, for example, was launched in 1990, a repair mission had to be launched in 1993. The mirror on the Hubble was not very well inspected, and its pictures were very blurry. Astronauts had to go up and execute a spectacular spacewalk to fix the mirror. After the fix, the pictures Hubble sent back were more precise than it was ever designed for. This is how an improved model appeared. That cannot happen with the James Webb Telescope. The Hubble orbits the Earth and is accessible to astronauts. The James Webb Space Telescope orbits the Sun and is well beyond the Moon, out of the reach of astronauts, because there is no spacecraft equipped to carry them there. It cannot be manually fixed if something goes wrong. Adding to the challenges, the James Webb Space Telescope has only one onboard camera to inspect any damage it may suffer or mechanical malfunctions that might develop in the harsh environment of interplanetary space. Any remote fixes will need to be done blind from Earth. The James Webb Space Telescope is now fully deployed. The 18 mirror segments will need to be aligned to produce a single image. This critically important process will take several months to complete once the telescope is fully deployed. 70 of the first 286 observation assignments of the telescope target exoplanets. Using data from previous exoplanet searches, it will not have to waste time searching for exoplanets. Their locations and orbits are already known. The James Webb Telescope will go right after them. The James Webb Space Telescope is not an optical telescope in the same sense as the Hubble Space Telescope or any ordinary telescope that sees visible light. It sees infrared light. The pictures of planets are expected to be bright dots, somewhat fuzzy if they have atmospheres. The spectra of the planets will yield the most information about the exoplanet. Any gases around an exoplanet will absorb some starlight as the starlight passes through the planet's atmospheres. Suppose there is methane in the planet's atmosphere, oxygen, or carbon dioxide, the gases that most indicate life. In that case, the James Webb Telescope will be able to pick them up by spectroscopic analysis. An entire portrait of the exoplanet can be formed from the infrared information, its temperature ranges, atmospheric content, the likelihood of liquid water, and even the probability of life. And that's a big deal. The James Webb Space Telescope has other missions to perform too. It's assigned to examine star formation and planet formation in nebula in the Milky Way. Understanding how solar systems form is part of the search for another Earth. By detecting infrared light, the James Webb Space Telescope will peer to the farthest away galaxies whose visible light gets blocked by dust and gas. These distant galaxies were formed shortly after the Big Bang. Galaxy formation is an essential mission for the James Webb Telescope. These most distant galaxies are accelerating away so fast that the light they emit is stretched below the frequency of the visible spectrum, into the infrared. The Great Telescope can see these previously invisible galaxies. We hope to learn about the mysterious dark energy that is causing the universe to expand at an ever-increasing velocity. Hope is high that the James Webb Space Telescope will significantly expand our knowledge of this amazing universe we all live in.
Okay, quick space riddle. Why is the search for life in the universe like a tree? Because you're always looking for a place to plant it. You know, plant it, planet. Okay, settle down. Anyway, water is the basis of life in any part of the universe, so potentially inhabited planets must have liquid water on them to support life. An incredible number of circumstances must come together for this. The planet must be in the habitable zone of the star. Then the temperature and atmospheric pressure on the planet's surface will be suitable for simple life forms to begin to evolve. A little closer to the star and the water will evaporate, leaving no chance for oceans and seas to form. This is what happened on Venus. It has a size and mass similar to the Earth, but it's too close to the Sun and no life can exist on its surface. Too far from the star, and the planet becomes too cold. Water can only exist in the form of ice on the surface, and there just might be liquid water deep below. Neptune is one example of this. In addition, the planet must be solid and have an atmosphere that protects it from solar radiation and allows living organisms to breathe. In our galaxy alone, there are countless stars. Really, you can't count on them. Near each one of them may be a planet. They're called exoplanets, and some of them may be in the habitable zone and have everything for life to form on them. From a list of 4,500 known exoplanets, scientists have identified 24 that can be superhabitable. This is the type of planet that is suitable for the existence and evolution of life, even more than the Earth. Such planets must be twice as massive as the Earth and 1.3 times larger. A bigger size means stronger gravity and a denser and warmer atmosphere. This will ensure a greater diversity of all living organisms on the planet. In addition, we should pay attention to the host star around which the superhabitable planets will orbit, and there should be a McDonald's nearby. Ideally, it should be smaller than the Sun and have a lifespan of at least 15 to 30 billion years. For comparison, the lifespan of the Sun is under 10 billion years, and it took about 4 billion for complex life forms to appear here. Stars such as the Sun can simply run out of fuel before life can develop on its exoplanet. Scientists suggest focusing on dwarf stars. They're smaller and less luminous than the Sun, but their lifespan can be between 20 and 70 billion years. This will give living organisms enough time to develop and evolve. Climatic conditions on superhabitable planets will also be different. The average temperature should be 8 degrees Fahrenheit higher than on Earth, and there should be more water in the form of clouds, liquid, and humidity. These conditions are the most favorable for biodiversity, so the whole planet would be looking like tropical forests on Earth. All 24 candidates for the title of Better Than Earth, are more than 100 light-years away from us. And with the advent of the new generation of telescopes, we'll probably be able to find out exactly if there is life there and if the conditions there are suitable for humans. Now, let's take a look at the potentially inhabited exoplanets. Tea Garden B.
It's an exoplanet that orbits a red dwarf star about 12 light-years away from the solar system. Typically, red dwarfs can emit flares that blow away the atmosphere of the planets in its orbit. But this host star is calm and relatively passive. Teegarden b has almost the same mass as the Earth. It makes a complete circle around its star in about 5 days. Yep, you got it right. A year on Teegarden b is less than a week on Earth. Hold on to your hats. The furthest potential inhabited planet is Kepler 1638b. It's in the constellation Cygnus, about 3,000 light-years away from us. It belongs to the Super-Earth class. It's twice as wide and 4 times as heavy as our home planet. The gravity on it will feel much stronger. Even a normal jump will be much harder for you than on Earth. Although, if this planet is really inhabited, local life is used to such conditions. LHS 1140b. This planet is very rocky and solid. Although its size is only 40% larger than the Earth, it's 7 times as massive. It has a strong gravity of 3.25 Gs. For comparison, when you take off on an airplane, you experience an overload of about 1.5 Gs. So on this planet, you'd barely be able to stand on your feet. Because of its large mass, this planet has a thicker atmosphere, and because of the greenhouse effect, its temperature can be above 19 degrees Fahrenheit, and it rotates around its star quite quickly. It makes a full circle in just 24 days. And now, let's look at the constellation Aquarius. Here's an ultra-cold dwarf, TRAPPIST-1. A small planet orbits in its habitable zone. It's 3 times lighter than the Earth. Its temperature is similar to ours, but the gravity is half as weak. But we would still feel comfortable there. Remember the people that went to the moon? There, the gravity is only 16% of the Earth's. That's what makes the astronauts move so funny. Kepler 452b is in a system that resembles the older sister of ours. The host star is only 11% older than our Sun and is almost 2 billion years older. The exoplanet itself is 6.5 billion years old, compared to 4.5 billion of Earth's. But these sisters are very far from each other. If you travel at the speed of the New Horizons spacecraft, it will take about 26 million years to get there. So bring a big lunch. This is the closest exoplanet to us, Proxima Centauri b. It orbits the red dwarf Proxima Centauri, which is the closest star to the Sun. This planet is just 4.2 light-years away from us. Its size and mass are very similar to those of the Earth. It probably has an icy structure, like Neptune. Although Proxima Centauri is the closest star after the Sun, we can't see it with the naked eye because it's too dim. So, all these planets, including the 24 that scientists have recently found, are in the habitable zone of their host stars. And, in theory, we can colonize them and make them suitable for human life in the future. But here we'll have to solve one big problem. Even the nearest exoplanet is too far away for us today. Our modern rockets can fly at 5 times the speed of sound, and even at such speeds, it will take us more than 100,000 years to get to Proxima Centauri on one of them. Well, we need to come up with something a bit faster to travel to a new home on one of these exoplanets. And perhaps scientists already have the answer. Warp drive. Ooh. This is a piece of technology that will allow us to manipulate space and time. It creates a kind of a bubble in which the normal laws of motion don't work. So the spacecraft will be able to significantly exceed the speed of light. And this isn't science fiction. Humanity already has such technology, although just in theory yet. It's Alcubierre warp drive. And no, I didn't make that up. Since no object that has mass can travel at the speed of light, we need to do one trick. The spacecraft has to move by compressing the space in front of it and expanding it behind it. Thus, not only the ship is moving, but also the space-time inside this warp drive bubble. And the maximum speed can be 10 times that of light. But to warp the space-time, the ship must be incredibly large. And to power it, will need the amount of energy close to what the whole planet of Jupiter generates. Still, recent calculations of NASA's Jet Propulsion Lab show that the ring around the ship, which should create the so-called warp field, shouldn't be perfectly round, as it was thought before. It can be more donut-shaped. Ah, donuts. This will greatly simplify the design and construction and will make it possible to test this technology on a spacecraft the size of a Voyager 1 probe. Even though it still seems impossible, scientists are already saying that there is hope. And while we don't know what technology will be used, in 2069, NASA plans to launch its first interstellar mission to explore potentially habitable planets outside of our solar system. Various rumors say that the speed of light can be achieved with laser technology. If the probe is very small, it can be launched to the Alpha Centauri star at almost the speed of light. There are also two other alternatives to power spaceships. These are nuclear energy and energy from matter and antimatter collisions. Ooh! These technologies are still a mystery to humanity, though. Well, for the time being, stay tuned.
2022 and 2023 have been landmark years for discovering new, fascinating worlds. Last year, NASA surpassed 5,000 confirmed exoplanets. The list is incredibly diverse. It includes rocky super-Earths, gas giants like Jupiter, ice giants like Neptune, and so on. And this is just the beginning. There might be more than 1 trillion exoplanets in our galaxy alone. But the most important question is, how many of them are habitable, for us? Are there any planets on this list that could have life on them? Or that could be a future home for us? Of course there are. And in 2022-2023, we found as many as 5 of them. So buckle up and hang on for a wild ride beyond our solar system. The first planet on our list is Wolf 1069b, a boring and stodgy designation. So I'll simply nickname it Wolfie, because hey, who's going to stop me, NASA? A new study conducted by 50 starry-eyed astronomers confirmed something awesome. This exoplanet, Wolfie, which is located just 31 light-years away from us, could potentially be a rocky world. In other words, theoretically, it's a habitable planet. The team behind this discovery used a technique called radial velocity to detect the exoplanet. This is a way scientists study the movements of stars and planets. It's as if when you're playing catch with a friend, as they throw the ball to you, you can see it coming closer and closer. It's kind of like radial velocity. When a planet is moving towards us, it makes the star it orbits appear to be coming closer to us. When the planet is moving away from us, it also makes the star look more distant. Scientists can use this information to figure out what the planet is doing and how big it is. And that's how they found Wolfie. This exoplanet is estimated to be the Earth's size and about 1 1/3 times the mass of our planet. It's orbiting a red dwarf star who I'll call Wolfie's mama. But here's the real kicker. Wolfie orbits within its star's habitable zone, which means it's a prime candidate for liquid water to exist on its surface. That's like hitting the exoplanetary jackpot. Ooh, wish I had a ticket. The study estimates that if Wolfie does have an Earth-like atmosphere, temperatures could rise as high as 55 degrees Fahrenheit, which would mean liquid water could pool on the planet's day side. But here's the catch. The exoplanet is tidally locked to its star, meaning that the same side always faces the star. Just imagine, one side of the planet is always basked in the warmth of its star, while the other is in eternal darkness. Like middle school. Just kidding. The team behind the discovery believes it's a prime candidate for further studies, but we'll probably have to wait another 10 years for answers. Until then, we'll just have to keep searching the skies with our telescopes and crossed fingers. Our next planet is TOI 700e. What's a good nickname? NASA has just discovered a new planet that's set to take the galaxies by storm, or shall we say by orbit. I'll nickname it Toys Were Us. It's almost the size of Earth, most likely has liquid water on its surface, and it's only 100 light-years away. We're not talking about a road trip, of course, but this is close enough in the grand scheme of things. Toys Were Us is the 4th planet in its system,
and it's got a bit of a short orbit, just 28 days to circle its star. Well, at least you would have a birthday every month. Hooray! This time, the discovery was made using the transit method. Planets themselves are incredibly small and hard to detect, but when a planet is in front of its star, it blocks some of the light coming from it, making it look a little bit dimmer. As soon as the planet moves away, the star gets brighter again. So, to find the planet, scientists watch very carefully to see if the star's brightness changes. If it does, that means there's probably a planet playing hide-and-seek with us. And that's how they discovered Toys Were Us. The TESS mission discovered it. It discovered 66 new exoplanets and 2,100 more candidates waiting to be confirmed. TESS has been very busy creating imaging for 75% of the sky. Talk about efficiency. Toys Were Us is located in the optimistic habitable zone, between planets C and D, but it may be tidally locked, just like Wolfie, so we might have to settle for a one-sided water world. The discovery of Toys Were Us is a promising prospect for future follow-up observations, and it demonstrates the potential for TESS to find even smaller exoplanets in the future. Who knows? It may find a new home for humanity among the stars one day, or at least a new vacation spot. Next, we have twins GJ1002b and GJ1002c. The galaxy just got a little bit closer to us with the discovery of two exoplanets, which I'll nickname Hansel and Gretel, that are just a stone's throw away from our solar system. That's right, these two Earth-like planets are located less than 16 light-years away, which is just a hop, skip, and a jump in space terms. For comparison, Proxima Centauri b is the closest Earth-mass exoplanet at 4.2 light-years away. So, these two new neighbors are among the closest to us. They both orbit a red dwarf star with barely 1/8 the mass of the Sun. It's quite cool and faint, but that's okay, since both planets are very close to it. Hansel takes 10 days to orbit its star, while Gretel takes just over 21 days. Even more birthdays, I guess. The discovery was made by an international scientific team and was no small feat. The team had to work together with two instruments, espresso and Carmini's. The result? A cafe latte. Nah. What they got were measurements so accurate, you could practically count the number of craters on the planet's surfaces. The big deal is, the planets are located in the habitable zone of their star and are just the right size, making them excellent candidates for future atmospheric studies. The lead author says, "Nature seems bent on showing us that Earth-like planets are very common. With these two, we now know 7 in planetary systems quite near to the Sun." Who knew our neighbors could be so friendly? In conclusion, the discovery of Hansel and Gretel is a giant leap for humankind. So let's all raise a glass of H2O, or whatever they drink on exoplanets, and celebrate it. The last planet on our list is LP890-9c, which I'll call Bob. This super-Earth, located about 98 light-years away, is roughly 40% larger than our home planet. Moreover, it has a twin, which I'll nickname Ray, which is up to 75% larger than Earth. More space is always good, right? The two planets orbit around the red dwarf star. Unfortunately, Ray is quite hot to the touch, with an estimated temperature of 253 degrees Fahrenheit, so don't touch. Its sibling, Bob, is located in the habitable zone of its star, making it a prime candidate for the potential of life. But let's remember that the actual temperature of the planets depends on their atmospheres. It's possible that Bob, being the outermost planet, has a runaway greenhouse effect, making it more like Venus than Earth. So it might be too hot to be habitable at all. But let's not lose hope yet. The James Webb Space Telescope, launched in December 2021, is on the case. With its cutting-edge technology and powerful instruments, including spectrographs, it can peer into the atmospheres of exoplanets and reveal which ones might be habitable. So let's see what it discovers. This planet has been listed as the second most favorable habitable zone terrestrial planet. Now it's on the list with 7 other Earth-like planets, all about 40 light-years away from us. Maybe they'll become our new homes in the future. Maybe we should fix the home we have. But until then, enjoy this moment and celebrate all these new discoveries. Who knows how many more planets we'll find in the future, considering how much technology develops each year? Thousands? Millions? Meanwhile, Bob and Ray, Hansel and Gretel, Toys R Us, Wolfie and her mama will all be out there waiting for us.
You take off from Earth and park your spacecraft somewhere near the Moon. You're now almost 240,000 miles away from your home planet. That's almost 100 widths of the United States. Now you take out a giant hammer and an enormous chisel using the robotic arms of your spaceship. You place the chisel at the Earth's North Pole and strike its head with the hammer. Earth splits open like an eggshell, and you see it, another planet. It's Theia, and it's hiding inside our planet like a yolk in an egg. You'd need to go back in time 4.5 billion years to find out how it got there. This beautiful nebula will soon become our solar system. Colored dust and various space debris are slowly coming closer toward the common center. Soon this jigsaw puzzle of debris becomes too heavy and dense. The temperature inside the giant is rising. Soon it gets so high that it triggers a nuclear chain reaction. Another second and bam! There's an explosion so powerful that the shock waves travel far into dark space. And the blinding flash from this blast can be seen from the other side of the Milky Way galaxy. When the dust clears a little, you can see that a bright light is still shining at the very center of the explosion. This newborn star is the Sun. It weighs as much as 333,000 Earths. If the Sun was a bucket, you'd need 1.3 million Earth-sized planets to fill it. You're interested in a small object over there, 93 million miles away from the Sun. This pile of rocks and hot lava is Earth. Right now, the planet is busy forming its core, while the oceans of lava are gradually cooling down. But a few tens of million years after the Sun's birth, you notice a strange object hurtling toward Earth. It's Theia. This small planet was born at about the same time as Earth, and now it's following a crazy spiral trajectory at enormous speed. Scientists believe Theia was kind of a ball Jupiter and Venus played with. Venus was pulling Theia in one direction. Then Big Brother Jupiter pulled it back. But the Sun makes up 99.8% of the mass of the entire solar system. That's why the star sets its own rules. It makes Theia move in almost the same orbit as Earth. So they inevitably come closer and closer to each other until they become next-door neighbors. We see that Theia is the size of Mars and as wide as the Atlantic Ocean from New York to Portugal. A collision can't be avoided. Theia is traveling toward Earth at nearly 9,000 miles per hour. That's 11 times faster than the speed of sound. If the smaller planet crashes into Earth at a particular angle, Earth will most likely be torn apart, as well as Theia itself. The collision will cause a huge blast, visible on other planets even on a bright day. Nothing will be left but some burning dust and debris. Even if Theia touches Earth only lightly, it'll still knock out a chunk of our planet the size of Australia. But the collision with Theia happens at a perfect 45-degree angle. It strikes the Earth at tremendous speed. The explosion literally vaporizes huge amounts of rock, and the shock wave sends the remaining debris into Earth's orbit. A huge crater is formed at the impact site. Soon it gets filled with boiling lava. The remnants of Theia and the ejected fragments of Earth begin to orbit our planet. According to one version, these fragments form two moons. At first, they travel together, but one day they get too close to each other and collide, forming one large space body. The other theory claims that all the shards start being pulled by the remnants of Theia. Sometime later, they form the moon as we now know it. At that point in the past, though, it's just red-hot rock and lava. The collision at this angle slightly tilts our planet and accelerates its rotation. It's because of Theia that we have different seasons and 24 hours in a day. Earth has lithospheric plates. These are enormous solid pieces that make up the crust of our planet. After the collision with Theia, they start to break and crack. It causes carbon, a primary component of all known life on Earth, to start moving all over our planet. So, Earth gets some kind of metabolism. After a few 100 million years, the first living creatures start to appear on our planet. Over nearly 4 billion years, Simple single-celled organisms have been evolving into the life you see today. According to scientists, such a collision is a very rare event. The probability that somewhere out there, there's a planet like ours that has survived the same catastrophe is extremely small. This may be the reason why we are yet to find traces of other civilizations out there in space. Meanwhile, the remains of Theia are still here on Earth. Of course, it doesn't look like an entire planet stuck inside our own. Most of the fragments have melted and blended into the Earth's crust. If you take the top layer off our planet, you'll see two huge lava blobs the size of entire continents. They're right below Africa and the Pacific Ocean. Presumably, these are the remains of Theia. They didn't mix with Earth's mantle because of different densities. It's like mixing water and oil in a glass. The oil will always float up over the water and create an even layer on top of it. But if you raise those lava patches up to the surface, they'd be 100 times higher than Mount Everest. Other remains of Theia might be on the moon. The Apollo space missions brought back many soil samples for analysis. Scientists have concluded that the moon is very similar to Earth in structure. People could drill deep down and take samples there. Then they'd analyze the blobs from Earth. If their structure matched, it'd be 100% proof that Theia did hit Earth 4.5 billion years ago. And that's how we got the moon. But for the time being, Theia remains somewhat mysterious. Scientists are still not sure that the planet actually existed. The whole idea perfectly fits the model of the moon's creation. But in fact, this incredible collision may have never happened.
Hop on the bright side of life together with our brand new tees, hoodies, and more. Click the link to pick your choice.
Now you travel 41 light years away from Earth to the planet 55 Cancri E. It's about twice the size of Earth and 8 times heavier. You take out your giant hammer again and use it to hit the chisel. The planet cracks, and you see it's a giant diamond. The temperature on this planet is tens of times higher than that of Earth, and its soil is rich in carbon. The heat puts a lot of pressure on this carbon. Its structure changes. First, it turns into graphite. Some more pressure, and graphite turns into diamond. On Earth, diamonds form at depths below 60 miles, where the pressure is 50,000 times greater than on the surface. The temperatures there rise over 1,000 degrees, which is as hot as fire. Diamonds are ejected closer to the surface in volcanic eruptions. Still, people have to dig mines 1,500 feet deep to find these beautiful gems. The Golden Jubilee diamond is the biggest cut and faceted diamond on Earth. It weighs as much as a chocolate bar and is the size of a hamster. Its price is about $12 million. Now imagine a diamond the size of an entire planet. You decide to fly back to the solar system. Your destination is Jupiter's moon, Europa. It's as wide as the distance between Seattle and Houston, and its mass is less than 1% the mass of Earth. Its surface is enclosed in an icy crust. It's about 19 miles thick. But what if you crack this crust with your giant hammer? Wow, Europa is completely covered in water. It's freezing here, 3 times colder than at the North Pole on Earth. The water turns into ice almost instantly, but the ocean beneath the surface is still liquid. Europa interacts with Jupiter gravitationally, just like the moon with Earth. This creates tidal forces and heats Europa's core. The core melts the ice around it. The result is a huge ocean, 2 to 3 times larger than all of Earth's oceans combined. Scientists believe that water is the basis of life. It may mean that life may exist on Europa. There could be thermal springs, just like at the bottom of our oceans. The water there is probably much warmer. And even though the pressure and temperature in such places are likely to be extreme, simple bacteria may live there. Europa is almost the same age as Earth. This means there's been enough time for living organisms to appear and evolve. Who knows? Maybe some advanced civilization is already blooming under this crust of ice. They may be building big cities and dreaming of conquering space right now. But the only thing people can do at the moment is send a probe to Europa and find out if life is possible there.
This is Neptune. The next stop is Pluto. Stand clear of the closing doors, please.
One day, with top-notch future technologies, one stop from Neptune to Pluto won't seem much further than Times Square from Bryant Park today. There are huge ice mountains on Pluto. Valleys that go further than your eyes can see, 160-mile large craters, almost as big as the largest one on Earth, and no life. The reasons are obvious. The long distance between Pluto and the Sun guarantees freezing temperatures on that dwarf planet. It also ensures a trip of a few billion miles. Plus, it's smaller than the Moon, so it would get crowded very soon if people started dwelling there. Still, there's one reason which makes life there not that far-fetched. The Sun has a lifespan and cycles within it. Our solar system used to be nothing but a cloud of gas and dust. As a result of a gravitational collapse at the center of this cloud, the gas and dust started gathering in specific, denser places. These pulled more and more matter as time went on, and something called conservation momentum made the mass start rotating and heating up because of immense pressure. Later, there appeared a disk similar to what Saturn has, but it was made of entirely different substances. And right in the center, there was the ball that eventually became the Sun. A protostar is a young star that's still gathering its mass, and that's exactly what the Sun was before the temperatures and pressures inside of it lighted up its core. Millions of years later, it became the Sun we see every day. But it won't stay this way forever. It will heat up even more and eventually get bigger and denser, turning into a red giant. It may one day get big enough to swallow up Venus and Mercury. Chances are, it might swallow even planet Earth. Even if it doesn't devour our planet, the Sun might get close enough to touch us. Well, if this happened, life on Earth wouldn't be possible. But then, in just a few minutes, the Sun loses about 40% of its mass and shrinks about 10 times what it used to be. It's not as bright, and indeed, not as hot as it used to be. By this moment, Earth will have already been deserted. People might want to start traveling around space, or settle down on another planet where life is sustainable, like the exoplanet Kepler-62f, which, by the way, is even bigger than Earth. While all of this was happening, Pluto was changing. Before, every resource was frozen inside of the dwarf planet. Water, gases like methane, carbon monoxide, you name it. But as the Sun was reaching its peak luminosity, Pluto was slowly warming up and losing a lot of what it had to the vastness of space. At the same time, an atmosphere formed up. If the atmosphere gets thick enough, it would create favorable life conditions. Then, instead of spaceships, a tiny percentage of us would be able to set up colonies on the dwarf planet. The temperature is comfortable there, almost t-shirt weather. It even resembles Earth a tiny bit. Canyons filled with water, beautiful endless fields with trees, and lots of space to run around, and mineral water pockets on the ground, good enough to drink. Pluto's rotations are different than Earth's. An Earth day is 24 hours, and sometimes it still feels like it never ends. But on Pluto, a whole rotation around the Sun takes 153 hours, because it's pretty far away from the Sun. After several hours without sleep, we get tired and our eyes get red. It means we'd have to take several naps throughout the day on Pluto. A year on Pluto equals 248 Earth years. Unless we come up with some sort of technology to get us to live that long, our entire lifespan would be less than half a year on the dwarf planet. So, houses on Pluto might need to be equipped with cryo chambers. Whenever you feel like dreaming for a long time, you jump in it and wake up 50 Pluto days later. On the dwarf planet, there are also seas and beaches. So it's just like a tiny Earth, far away from the actual Earth. The food on Pluto could be tastier. We might find a way to make the ingredients more savory and even try to grow them faster during the trip. You plant a carrot, and 2 days later, it's ready to be in your salad. There could also be new ingredients for our salads on Pluto. Maybe 2-meter-tall mushrooms we've never seen before. The animals we would take with us on the trip would get released into their new home forever. And with time, they would evolve and adapt to their new environments. The law of the jungle could change a bit too. Lions might not be kings anymore. Deer are. Their antlers are twice the size of what they used to be. But to be fair, so are the deer. Most of the animals that were already here used to live underwater. But with time, the amphibians started shifting to the surface, just like Earth at the beginning of life. Pluto could only be a temporary home though. Once the Sun has finally reached its final phase, Pluto would get frozen and lifeless again. People instead would need to try to find a planet that stays in the Goldilocks zone of another galaxy. The Goldilocks zone is the exact proper distance from the star like the Sun, where the temperature is perfect for the water to stay liquid. It's the rule scientists search for when looking for other planets that can sustain life. We can try setting new colonies on one such planet, or even try to set up our own artificial home. Not exactly a planet or a spaceship, but a combination of both. Something huge built right in space, say a wheel with gravity everywhere we go, so we don't fall off. It would float in space toward the new exoplanet, capable of fitting entire states in. This whole trip might happen just because the Sun first grew too much, and then, having reached the culmination of its life cycle, it would finally become a white dwarf. It's going to be a pretty long journey, and entire generations will be born here. You'll have a choice: sleep your way through the journey until humans finally reach their new exoplanet, or enjoy the trip in this fantastic spaceship. There's all you need on board: malls bigger than those on Earth, large futuristic cities, even places to farm, fields with rich soil made artificially, and finally, after a long journey, the exoplanet. It's even somewhat better than Earth. The planet is giant and has more continents. The continent's center isn't as far from oceans, which means there aren't as many desert areas. Though the sun of this planet is an orange dwarf, it's not as hot as our yellow dwarf sun today. It's a bit smaller, but here's the kick: orange dwarfs live somewhat longer. They remain stable for between 15 billion and 45 billion years. Despite that, this new planet is full of rainforests because the planet itself is warmer. It means more biodiversity and creatures we've never seen before. But even if nothing out there is suitable, we could try and terraform this planet instead. If we take Mars as an example, we could create a greenhouse effect by smashing ice-rich comets and releasing ammonia in them, making the planet warmer. We could also start planting trees. We'd probably need some Earth soil to do that, or we'd have to modify Mars's soil to be similar to ours. Sooner rather than later, the atmosphere would be close to the one we have on Earth. We'd be able to breathe too, because of the trees. Then, we can melt Mars's polar ice caps and voila, water. The problem is the solar winds and sun explosions that might strip it of an atmosphere just as quickly as we can create one, if not faster. It has no magnetosphere either, which means it can't protect us from radiation, so long-term Mars wouldn't be a good choice. Maybe out there, in the vastness that is space, there is a perfect planet waiting for us. We'll start with one of the most recent and shocking discoveries of 2020. Perhaps our solar system has life beyond Earth. This is Venus, the second planet from the Sun and the sister of our home planet. It's called so because it has a similar size and mass, but the conditions on it are simply terrible. The temperature on its surface reaches 890 degrees Fahrenheit because of the greenhouse effect, and the atmospheric pressure on it is as strong as if you were 3,000 feet underwater. But in this hostile world, there can actually be life. For many years, there have been discussions on this subject. In 2007, scientists discovered there once had been an ocean on Venus. That is, in the distant past, there could have been some form of life. But in the fall of 2020, there was an epic argument in which scientists tried to find out whether life on Venus exists right now. In September, the discovery of a new life marker on Venus was announced. The ALMA telescope in the Atacama Desert found phosphine gas above the planet, and the amount of this gas suggested that it may have been produced by certain microorganisms. But already in October, the data was analyzed again, and the new results indicate it was an error. So today, we consider Venus to be uninhabited once more. But who knows? Maybe soon we'll get new data, and new disputes will arise in scientific circles. And while some scientists are scratching their heads and still concentrating on Venus, others have looked into distant space and discovered 24 planets on which life can exist. And on all of them, living conditions are much better than on Earth. Such planets are called superhabitable. These superplanets must be 1.3 times larger than the Earth and twice as massive. Thus, they will have stronger gravity and, as a consequence, a denser and warmer atmosphere. So, the climate on superhabitable planets must be similar to the tropical climate on Earth. This will ensure the maximum diversity of living organisms. The host star of such a planet must be a red dwarf. They're much smaller than the Sun and not so bright, but their lifespan can reach 70 billion years. For comparison, the lifespan of the Sun is 7 times shorter, and it's already past half of it. Slow and steady wins the race. It will give enough time for potential life to develop and evolve. And here's a suitable planet for the title of superhabitable, Kepler 1649c. In 2020, it was named the most similar planet to Earth. It's only 6% larger than our home world. It orbits a red dwarf, a quarter the size of our Sun. The planet is in the habitable zone of the star and makes a complete circle around it in 19.5 days. The climate on Kepler remains a mystery. It's known to receive about 75% of the light we get from the Sun, so the temperature on its surface may be close to Earth's, but we still don't know the composition of the atmosphere and other necessary conditions for life to appear there. The next discovery is one of the most amazing spectacles ever seen by humanity. It's the collision of a star with a black hole. In September 2019, scientists began watching how, for 6 months, a Sun-like star was being spaghettified. Light from this event traveled 215 million light-years, and we saw a star about 860,000 miles wide slurped up by a black hole. This black disk is so heavy that it has incredibly strong gravity. Nothing can leave its gravitational field. And now we see a star slowly approaching it. First, the glowing light layers of the star begin to stretch towards the black hole. It looks as if the star is simply unrolling like a ball of thread. Then we see this hot plasma lingering at the edges of the black hole. And it may seem these particles are now orbiting it, but it's just an illusion. This ring of light is called the event horizon. The black hole curves not only space, but time as well. This close to it, time slows down. To the observer, it looks as if the light near the edge of the black disk has almost stopped. But in fact, it has long been absorbed by the dark abyss. When a black hole eats a certain amount of star material, it starts spitting it out. Powerful beams of energy are ejected at speeds of over 6,000 miles per second. This is the light that attracted scientists' attention. In the end, the black hole has completely absorbed about half of the star and spit out the other half into space. And even though we watched this process for only a couple of minutes, it was happening for 6 months. And here is one of the youngest planetary systems that humanity has ever observed, AU Microscopii. It's so young, there's still a disk around it from the debris this system was made of. But this time, we don't even hope to find life here. The host star of this exoplanet continually emits radiation flares that would wipe out any form of life from the planet's surface. The planet that orbits this dangerous star is called AU Mc-B, and it's just a newborn baby by astronomical standards. It's so close to its star that it makes a complete circle around it in 8.5 days. The age of this planet is only 12 million years, so at the time AU Mc-B was born, mastodons walked on the surface of our planet, and meadows and savannas were covering the Earth's face. So you and I can consider ourselves old-timers, because the age of the Earth is almost 4.5 billion years. The next discovery took place in early 2020, and it's very similar to a landscape from science fiction. It's a planet with 2 suns. Well, more precisely, it doesn't orbit around a single star, as we are used to in our solar system, but around a binary star system, TOI 1338. The first big star is like the Sun. The other is a red dwarf, which is 3 times smaller. These stars completely circle each other in a little over 14 days. The planet that orbits these stars is the size of Saturn, which is much larger than the Earth. Although the sunsets and sunrises there look incredibly beautiful, This planet is unlikely to be suitable for any form of life. It's outside the habitable zone of its host stars, so it probably doesn't have liquid water. Mysterious radio signals from outer space have also been received in 2020. We're talking about fast radio bursts. Scientists recorded such signals before, but recently they have managed to prove that they are repeated after a certain period of time. The new data have forced the scientists to come up with a very bold theory that their source may be a magnetar. A magnetar is a neutron star that is small and has a huge mass compared to ordinary stars like the Sun. But they have the strongest magnetic field in the entire universe. Their lifetime is very short though, only 1 million years. But what baffled scientists the most this year was discovering that the moon is rusting. Corrosion needs oxygen and water to take place, but the moon doesn't have its own atmosphere to have both. The main theory says the solar wind is to blame. It moves at great speed and scrapes oxygen from the upper layers of the Earth's atmosphere. The wind continues to carry oxygen molecules through space, and eventually they reach the surface of the moon and cause metal ore to rust. By the way, the signature red color of Mars was created because of the rust. For a long time, there was an atmosphere and water. In combination with iron on its surface, it triggered a long process of rusting, which has lasted since ancient times. Another stunning discovery was found on the surface of the moon with a stratospheric telescope. It's an aircraft that carries a telescope. The plane raises it to an altitude of 8 miles, and this allows it to have a picture quality comparable to that of space telescopes. And with the help of such an unusual observatory, scientists were able to find water on the surface of the moon. Water molecules were found in one of the largest craters on the visible side of the satellite, but the number of water molecules is still extremely small there. The Sahara Desert has about 100 times more water than the surface of the moon. Among all the planets of the solar system, our Earth is unique, since it's the only one that has developed life. But what if we got a competitor? What if a second Earth appeared out of nowhere? Then there would be two different scenarios. The first is the destruction of both planets. The second has an unexpected but pretty logical ending. But let's start with the catastrophic scenario. The second Earth with the same conditions could only exist if it received absolutely the same amount of sunlight as our planet. The orbit that our Earth follows is perfect for getting the necessary amount of solar heat. If we were a little further away, the entire surface of our planet would resemble Antarctica. And if Earth were a little closer to the Sun, we'd all live in a huge desert, inhabited by very few living beings. So, for the second Earth to be identical to ours, it would need to follow the orbit of our planet. Two massive objects can exist close to each other. The union of Earth and the Moon is a great example. But if the second object was as heavy and huge as our planet, there wouldn't be enough space for both of them. The gravity of two Earths would be a huge problem. The two worlds would collide because they would be pulled toward each other. This process would last for hundreds of millions of years. And in the end, the two planets would transform into one giant world. And their remnants would be flying around the newly formed planet, resembling the rings around Saturn. Or one of the planets would push the other out of its orbit. In this case, one of the Earths would hurtle toward the Sun and burn like a match in its atmosphere. It's also important to remember that Earth is moving at a speed of 67,000 miles per hour at all times. This is more than 80 times faster than the speed of sound. And now, imagine two huge planets that are flying toward each other at such a speed. Even a microscopic organism living in the mouth of a volcano wouldn't stand a chance to survive the collision of two Earths. Even the Moon would be torn to pieces by the blast wave. But let's imagine that Earth's twin is following another orbit, somewhere between Mars and Earth. Even in this situation, people's lives would change forever. By the way, the theory that Earth might have a twin appeared long ago. Scientists of the past believed that the second planet could be hiding on the opposite side of the Sun. thanks to modern technologies in astronomy, we know this theory isn't true. Otherwise, our telescopes and other equipment would have already caught some signals from this planet. Scientists study space objects thousands of light years away from us, so they would definitely notice another world in the neighborhood. But anyway, let's imagine that the second Earth does exist, and we've discovered it recently. The entire field of astronomy and astrophysics will immediately receive hundreds of billions of dollars in funding. The study of Earth's twin will become a priority goal for people. Experts will put forward hundreds of hypotheses about what the second Earth looks like and what's happening there. The planet is almost at the same distance from the sun as we are. This means the weather must be the same there. Soon, scientists find out that Earth's doppelganger has liquid water and continents, but they aren't like ours. Their shapes and location are different. Most likely, life exists there too. But what is its origin? There's a hypothesis that life on our planet appeared thanks to amino acids brought here by a meteorite. It's highly improbable that the same thing happened to another world. Life most likely emerged there in a completely different way. Perhaps the fish didn't get out of the water on that planet, and the first intelligent creatures appeared in the ocean. These could be amphibians with scales and fins, or octopus-like monsters with huge tentacles. Fish on the second Earth could have come out of the water and grown limbs. But what if they didn't like walking on the ground? Then, this world might be inhabited by intelligent bird people. Or, life could have originated deep in the soil. Then evolution would create humanoid moles or highly developed worms. To find out for sure, scientists send a rover there. A similar mission to Mars was a success, so there shouldn't be any problems with this one. People on Earth are waiting. What will the rover find on the other side? It will take several years for the ship to get there. Strangely, 2 days after the launch, it returns. But wait, this is not our space probe. All this time, the inhabitants of the second Earth have been watching our planet too. At one point, they also sent a probe. It's made of the same materials as ours. It has a camera and a recording device. But people are worried because the rover looks similar to a mechanical spider. Can it be that giant tarantulas live in that world? Scientists understand that we need to communicate. We send our guests a radio signal with some information about our civilization. They catch this message and send their own. It contains strange symbols that resemble scratches. Linguists all over the world are trying to decipher it. Meanwhile, astronomers send the guests a recording of human speech. A few days later, our satellites catch a message from our space neighbors with their voices. Scientists are about to play the recording. The whole world is listening with bated breath, and it's a growl. A terrible and absolutely incomprehensible growl. It has pauses and an unusual rhythm, but it's nothing resembling human speech. The whole planet is panicking. All countries are preparing for an invasion. The most important thing now is to build shields to protect the planet. No one can decrypt the message. It's possible that our neighbors can't understand us either. People make a last attempt to establish some contact. We send a video to explain to our guests with the help of gestures and signs that we only want peace and collaboration. The answer doesn't take long to wait. Our satellite receives their video file. Scientists play back the recording, and it's shocking! We see dinosaurs in robotic suits! Life on the second Earth has been developing in the same way as on our planet. But the infamous colossal meteorite didn't fall there. Over millions of years of evolution, dinosaurs have become sentient. In the video, they're growling and pointing with their claws at the picture of our Earth. Then they start growling even more loudly, and is it laughter? The recording ends. People consider this the announcement of the invasion. Several years have passed. During this time, scientists have exchanged messages with dinosaurs several times, and it seems we're beginning to understand them. It turns out that the reptiles also want peace. They say that their planet was once inhabited by humanoids similar to humans, but a massive flood wiped them away. Dinosaurs managed to survive and evolve into intelligent beings. It will take many years before people set foot on their planet, and when this happens, humanity will feel relieved, realizing that we're not alone. But what if there was no intelligent life on the second Earth? people would also be happy. We would know that we'd always have another home. Perhaps we'd start exploring Earth's twin right away, or begin mining its resources to replenish ours. In any case, our lives wouldn't change immediately, because that land would be too far away from our planet. Dozens of generations would pass before people begin settling on the second Earth. Our homeland planet would be losing more and more resources, so everyone would want to move to a new world. In the beginning, only the richest would be able to do it, but with time, space travel would become cheaper. People would probably invest a lot of money to build a paradise on the second Earth. If this happened, we'd be visiting this world during our vacation to breathe fresh air and enjoy nature. In any case, the human population would grow. This means that sooner or later, the second Earth would become as loaded as the first one, and then people would start searching for a new home among the stars. By the way, if any life exists on a planet similar to ours, it's likely to look like octopuses. There's even a theory that octopuses came to Earth from some other world. Any animal has several evolutionary stages of development. For example, elephants and mammoths descended from one common ancestor 5 to 6 million years ago. Looking even further, almost all mammals evolved from one ancestor they shared with reptiles. Each species has been changing over millions of years. But not octopuses. They suddenly appeared on a family tree. From the point of view of evolution, squids would have to evolve into octopuses millions of years from now. But look, they're already here. Besides, octopuses are incredibly smart. Their genetic code is much more diverse than the human one. They may be visitors from another planet that is similar to ours. But of course, this is only a hypothesis.
Hop on! I've prepared a tour around Earth's fellow planets. Let's start with Mercury, the smallest planet in the solar system. During the day, the temperature on the surface of this planet can reach 800 degrees Fahrenheit, and during the night, it can drop to negative 290 degrees Fahrenheit. The temperatures here are so extreme because the planet has no atmosphere. Instead of it, Mercury has a thin exosphere. That's one of the reasons why Mercury is not habitable. The temperatures and solar radiation are too extreme for any organism to survive there. Now let's imagine there's a way to live on Mercury. Then what would life there look like? Mercury's surface resembles that of the Moon. Over time, meteorites left lots of marks on it. Unlike the Moon's surface, Mercury is grayish-brown. Now look up. The sun on Mercury would appear almost 3 times as large as it does on Earth. The sunlight would be almost 7 times brighter. I wonder what type of sunglasses people would wear if we lived there. Can life appear on this planet in the future? Don't get your hopes up, it's very unlikely. Now, how about landing on Venus? You might think the hottest planet in our solar system is Mercury since it's the closest to the sun. But in reality, this title goes to Venus. What is it that makes Venus boil? The biggest reason is its atmosphere. It's made up almost entirely of carbon dioxide. The atmosphere is so thick that it leads to the planet warming up non-stop. Basically, the gases in the atmosphere prevent thermal radiation from leaving Venus. So, the planet simply can't cool down. The water on its surface constantly turns into vapor. If the surface of Venus was food, then its atmosphere would be the microwave. That's why the temperatures in this world can go up to 870 degrees Fahrenheit. What would it be like to live on Venus? On Earth, seasons change because of the planet's tilt, but Venus doesn't experience any significant changes throughout the year. Things are pretty constant at night and during the day too. And what about the view of the sky? The clouds on Venus appear yellow or bright white. They're mostly made of poisonous sulfuric acid, but then why does Venus appear reddish-orange when you look at it from Earth? Talking about the true colors of planets can be a tricky business. The hue of a space body might be different when you look at it from another planet. If we traveled all the way to Venus, a reddish-brown surface would welcome us. The molecules of carbon dioxide and sulfuric acid block sunlight coming into Venus's surface, hence the reddish-orange color of the planet. Oh, and did you know that Venus is often called Earth's twin? Both planets are nearly equal in size. Both have relatively young surfaces and thick atmospheres with clouds. Plus, the orbit of Venus is also the closest to Earth. That might raise a question about the possibility of life on Venus. I'm sorry to break the news, but nope. Venus is not habitable. The next destination is Mars. Unlike Venus, Mars has seasons due to the planet's tilt on its axis. It also has a secondary seasonal effect caused by its highly elliptical orbit. The southern hemisphere has colder winters and hotter summers than those in the northern hemisphere. The average temperature on Mars is negative 80 degrees Fahrenheit. But temperatures can also range from the poles to the equator, and they can change very dramatically within a single week. Still, not that bad compared to the previous two planets, huh? Is Mars habitable? The number one thing a living organism should worry about here is space radiation. Earth has a magnetic field and a thick atmosphere to protect its surface from radiation. Mars has neither. The planet's gravity is 1/3 of Earth's. So, weaker gravity and a thinner atmosphere make it harder for any living being to survive on the red planet. In 2013, NASA reported an ancient freshwater lake that could have been a hospitable environment for microbial life. This is evidence now that liquid water once flowed on Mars. This confirmation suggests that Mars could have had the necessary environment to support life. But what happened to the water on Mars? The most popular explanation is that the planet's atmosphere became too thin and cold to keep liquid water on Mars's surface. The disappearance of water might also be related to the loss of early magnetic fields. Or the reason might be the red planet's size. Mars is probably too small to keep water. So, for now, Mars is not habitable. But, scientists keep sending missions to Mars. Maybe they'll find some new information. Let's wait and see. Now, Jupiter. Have you ever wondered what it might be like to live on the biggest planet in our solar system? Jupiter's environment is an unlikely place to support life. The temperatures on this planet and its composition are too extreme for any organisms to appear there. Jupiter has layers of gas, mostly hydrogen and helium. These gases fill the entire planet. Quite literally, there is no solid surface on the planet. Gases go all the way to the core, below the surface. They become liquid and turn into plasma because the atmospheric pressure there is way more intense than any place on Earth. To put it into perspective, an organism on Jupiter has to resist 1,000 times more atmospheric pressure than it would on Earth. Can a living being survive in such conditions? Unlikely. Jupiter is completely uninhabitable. But hey, have you heard that its moon Europa might be a possible habitable zone? Change of scenery. Saturn. It's the second largest planet in our solar system. Like Jupiter, Saturn is a gas giant ball mainly consisting of hydrogen and helium. What about temperatures on Saturn? It's freezing. Plus, there are extremely powerful winds there. The winds in Saturn's upper atmosphere reach the speed of 1,600 feet per second. Let's compare them to storms on Earth to have a better understanding. The strongest hurricane ever recorded on Earth was moving at 350 feet per second. So the answer to the question, is there life on Saturn? Seems pretty obvious. Life, as we understand it, doesn't exist there. The next stop is Uranus, one of the largest ice giants. Uranus's atmosphere is dominated by ice, but it's not the only reason that causes the planet's blue color. It's also the methane in the atmosphere. It absorbs red light and reflects blue. The same goes for Neptune. Uranus is the coldest planet in the solar system. The temperatures there can be as low as negative 371 degrees Fahrenheit. Life on Earth needs sunlight to get energy, but there's nothing on Uranus that can produce any energy for life forms to thrive. The bottom line is Uranus doesn't have the environment to sustain life. Heading for Neptune, the second ice giant. What is there on the planet furthest from the sun? Obviously, it's incredibly chilly. There's neither a source of energy that bacterial life can exploit, nor a source of liquid water. Currently, scientists believe it's unlikely to find life on Neptune because of such unfriendly conditions. So, what makes our planet so livable? And I'm not just talking about human life, I mean any living organisms, even microbes. Life requires very special conditions to exist. All living beings need some sort of food, water, and the right temperature to develop. The atmosphere is a vital element. Humans, for instance, need oxygen to breathe, and they can only survive in temperatures that aren't extremely hot or cold. Another thing is gravity. All the other planets I've mentioned don't have exactly the same conditions as Earth. Life there would probably be different than what we have here. All living beings on Earth have adapted to our atmosphere, and life forms elsewhere would need to be able to survive in that planet's conditions.
Is that Earth you can see at a distance? Right. Just look at it, floating in space, hanging out with its planet buddies. You spot orange-red Mars and Jupiter with its asteroid belt. Even tiny Pluto is there. All these planets keep their distance from each other, moving along in their own orbits. They're not very social, you see, but that's a good thing. It would cause nothing but trouble if they started to bump into each other. But even though there are others, Earth is the only planet we know that has life. And we've even figured out why. It's because it was lucky enough to appear in the best spot in our solar system, in the Goldilocks zone. Scientists say the key ingredient for life is water. But, well, there's water on Mercury. This planet has deposits of water ice at its south and north poles, but only because those places never see the light. Everywhere else, water simply evaporates from the surface of the planet. Mercury is way too close to the sun. Pluto has some water too. Astronomers even think the dwarf planet might be up to 30% water, but it's frozen. Unlike Mercury, Pluto's too far away from the sun, which is why all its water is in the form of ice. But Earth hovers in a perfect spot called the habitable zone. It has the right temperature for the water to remain liquid and for all forms of life to flourish. But what if Earth was the only planet in the solar system? No Mars, no Jupiter, no Mercury, no Venus. Things might have turned out a little different than what we're used to. Remember that massive asteroid that hit the Earth around 66 million years ago? Well, without Jupiter and its asteroid belt, our planet would be constantly hit by meteorites and asteroids, and some of them would be just as big as the one that caused all that sorrow to the dinosaurs. These rocky fellas would be roaming around in space with no one and nothing to stop them. And if Earth was the only planet out there, it would also be their only target. But that's not all. Look at all this huge space Earth would have all to itself. It means our planet would have an opportunity to travel a bit. It could even choose to leave the Goldilocks zone. But then, would life on the planet still be the same? So let's say Earth started drifting away from the sun. Then, it'd soon get too cold on the planet. Picture a place where the sun doesn't shine anymore. Dark, cold, covered in ice and snow all year round. That would be our Earth if it traveled further from the sun. If this happened, our cities would start to look very different. Right now, Earth is full of life. Come to any park and you'll see green trees and grass everywhere. There will be people walking, sitting on the benches, enjoying the sun. You'll definitely spot someone playing soccer or frisbee. On the park's lawns, there will be people resting on their blankets, soaking up the sun. A few people will be reading their books, looking relaxed and happy. Back in space, you see Earth again. The planet is still in its favorite spot. That's why life is so beautiful down there. But wait, is it moving? Our planet is definitely further from the sun now. Has it changed things for Earth? It actually looks a bit bluer now. Down there, famous golden California is not so golden anymore. It's gloomy and dark, much like all other places on Earth. New York is covered in ice. Even in the hottest places, the temperatures are now below freezing, including tropical destinations like the Bahamas. After a while, liquid water turns into ice. The oceans now look like giant skating rinks, except there's no one to skate there since the planet has become way too cold to support life. Okay, then what if, instead of drifting further away from the sun, Earth moved closer, with people still aboard? Whoa, the temperatures here are crazy, too hot to handle. The climate would be getting hotter and hotter. Natural disasters would start to occur more often. Hurricanes and floods would be a common thing on Earth now. And pretty soon, the planet would get too hot for people to handle. Particles from the sun would become a serious threat. The atmosphere would be struggling to protect Earth from solar radiation, but this shield would be growing weaker. Liquid water would be nowhere to be found anymore, maybe only in underground deposits. Earth would look a bit like Mars, all rocky and barren. The Mississippi River would dry up and leave behind a huge canyon. All the oceans would be gone too. At the moment, the Mariana Trench is the deepest known place on Earth. It's incredibly hard to reach its bottom because of the immense water pressure there. But without water, trips to the deepest spot on Earth would be possible. It would help people uncover some more of Earth's secrets. If people still lived on the dry and scorching hot planet, that is. In other words, if someone was to explore Earth after the planet had moved closer to the sun, everything would be completely different. But what if Earth didn't move at all and everything remained the same? The only difference, there would be no other planets around us. It would change the way people explore space. Sure, there would still be navigation, communication, and weather satellites, and maybe space telescopes. But there wouldn't be any other space objects close enough for people to send missions there. This would affect the future too. If people had no desire or opportunity to go to space, they would invest in their home planet. They would build sky cities instead of looking for other planets to colonize. These days, if you get a state-of-the-art telescope, you'll see distant stars and other planets. The better the telescope, the more detail there is for you to see. But with no other planets out there, the picture of space wouldn't be so exciting. Stars would still be visible, and you might even spot a meteorite or two. And you'd definitely see the moon, but that's about it. Space agencies would mostly be focused on keeping Earth secure, mainly because asteroids would become frequent visitors. To protect the planet, scientists would have to figure out ways to get rid of them. Like a massive laser beam. When turned on, it could go all the way to the moon and even further. Instead of building rockets to explore space, SpaceX and NASA would be in the asteroid clearing business. People wouldn't even think of trying to contact other civilizations. If there were no planets similar to Earth, they would consider it a wasted effort. This means no radio signals being constantly sent out to space. A curious fact, in February of 2008, the Beatles song Across the Universe was beamed into deep space. It was done to celebrate both the song's 40th anniversary and NASA's 50th anniversary. In the 70s, people also sent a radio signal out into space. It contained some basic information about humans and the solar system. But it was more a feat of strength for technology than an attempt to contact any alien buddies we might have. With no planets around, the world of sci-fi would change too. There would be no more movies about deep space exploration. No massive spaceships and rockets would appear on the big screen. And since there would be no expeditions to other planets, no rovers would be sent to space to look for signs of life and explore new worlds, like what the rovers on Mars are doing right now. People would concentrate more on their own planet. For example, they would begin to explore its insides. New technologies would allow us to dig much, much deeper, all the way through Earth's crust and further. And doesn't a trip to the planet's core sound exciting? Instead of astronauts, there would be explorers of the deep underground. New drilling technologies would be invented to make the digging process more effective. There would be new types of vehicles. They would be created to drill and protect explorers from the enormous underground pressure. While exploring the world under the planet's surface, people would likely find absolutely new life forms. Those would be mysterious creatures that evolved to survive in the dark, in extreme temperatures, and with barely any food. It certainly helped people understand more about their home planet.